Hey guys, hello everyone and welcome to the channel. So CSIR has now provided with the response sheet for you guys, like whatever questions you guys have attempted in CSIR December 2024 exam. And they have also released provisional answer key, and they have given 2-3 days so that you can challenge questions if you think that there is any answer in the provisional answer key that needs to be challenged. So in this video, I'm going to take two of those such questions which you guys have requested me to look upon. There are a lot of questions which you guys have asked, but these are the most requested ones. I'm looking into others also, and I'll be making those videos very soon, but these are the two most requested ones. So let's talk about them. So this is question number 701158 and question number 701107. Okay, so we'll talk about them. Why is it challengeable? Why not? So let's look upon that. First of all, before going into that, I would like to thank all of you who have taken out your time and shared your like question paper and provisional answer key with me, because I am not in India right now, so it was difficult for me to get all these things. But yeah, thank you so much for that. Thank you so much once again to all of you who have sent me on my email. So now let's look upon the questions one by one. So this was the question over here, and it was asked for 2 marks in part B, and it says that the radii of cation and anion in an ionic compound are 74 picometer and 170 picometer respectively. The coordination number of this cation and the best possible geometry of the compound are. Okay, the answer which is given according to the answer key is first option, which says that 4 and tetrahedral. So this question was very straightforward. Okay, if you have studied solid state chemistry, I think most of you have done it right. So you know that the coordination number, it depends upon a factor which is called as radius ratio rule, right? And if you see that radius ratio rule, there is a table which we have. So if your radius ratio falls within a particular range, then you can calculate coordination number according to that. All right. So if you will see any standard book of physical chemistry, you will see that the range is like, if you have 0 to 0.15, then there is a range from uh, 0.15 to 0.225. Okay, then you have 0.225 to 0.414, then you have 0.414 to 0.732, and then 0.732 to 1.0, and the coordination number for this range is linear. Okay, linear, and 2 is the coordination number for this. Then for this you have triangular, and coordination number is 3. For this we have tetrahedral, and coordination number is 4. For this it is octahedral, coordination number is 6, and for this it is cubic. Okay, and coordination number is 8. So this question can be easily solved. You are given with the ratio of cation and ratio of anion. You know that radius ratio is basically r plus upon r minus, means ratio of cation divided by ratio of anion. So you will have, because units are same, so no technicality here, 74 divided by 170. And if you use your calculator to do this calculation, so basically you are going to get 74 divided by 170 should give you a value of 0.435. Okay, if you round it off, yeah, this is what you will get, 0.435. If you see this range, it falls in this particular range, right? And that's why the answer should be octahedral, which is option number 2, which is not the given answer. So this is definitely challengeable question. And because I try to look upon, because whenever this type of question comes, I first try to look upon like why answer key is right, okay, or why answer key could be right, but there is no explanation for that, because we are not given with any specific cation or a specific anion, so that we can even have a doubt of exceptional case. There is no exceptional case here, just normal calculation, just normal mathematics or normal like division is used. Everything is same, and that's why it should be option 2, and you can easily challenge this question if you want to have reference of this. So for reference you can use, like, for reference you can use any standard book, you can use any book of which has solid state in there. Okay, so you can use solid state chemistry book. Okay, you can even use Puri Sharma, that's a very well known book, Puri Sharma Pathania, and you can just like take a screenshot of that formula and do the calculation on MS Word properly, and just like this. Okay, just like this, and you can submit this particular question. So if you are planning to challenge this question, you have to pay 200 rupees for this, and I hope and I believe that this is challengeable. Definitely you should be getting marks for this question. Okay, it's a 2-marker question. It might be very crucial for many of you. Okay, all right, let's talk about the next question. This is very favorite question of mine because very good question. Okay, let's look upon this. Okay, it says that the shortest distance on the surface between two opposite corners of a cube having side of 1 unit length is closest to how much? Very good question. Okay, let me show you, because why I like such questions, because these are questions which make you think twice, and these are like logic based questions. So let's see. Okay, the answer which they have given, first of all let me tell you, the answer which they have given is option 4. Okay, this is the answer according to the key. Okay, this is according to the provisional key. So let's talk about this question. So first of all, I'll draw this cube for you. Okay, and I am trying to be very precise when I'm drawing a cube, because everything here depends on how you are looking at the cube, the perspective. Okay, so just for the sake of explanation, let me tell you that these dotted lines are away from you. So this is a face which is towards you. Okay, cube has 6 faces. So this is a 3D figure, of course. So this is towards you, and this face is back side of you, away from you. This is on the left side, this face on the right side, this is in the bottom top. Okay, so the atoms, where these atoms are placed, so these are placed on the two opposite corners. So one corner is this and one corner is this. These are the two opposite. You can take any two opposite corners of the cube, and this is what it is. So what you guys are thinking, and what I'm like, I can see from the comments which you guys have given, that you guys are thinking that the answer should be 1.73. Okay, why? Because they are asking about the opposite corner, and this is going to be the shortest distance. This is basically body diagonal, right? Body diagonal, and we know that the value of body diagonal is √3, which is 1.73, and many of you have answered this, option 1. Some of you have also gone little creative and answered it as option 2, because the logic which I have read in the comments is that because it is asked on the surface, so this is on the surface, and that's why it should be option 2. But let me tell you that answer key is right. Okay, I'll show you how this will be done. Okay, so now is where all the logical thinking is going to come. By the way, this question was in part A. Okay, aptitude portion. That's why I love aptitude. Okay, let me draw this cube again for you. See, the question says that you have to reach out to the atoms on the surface. Okay, distance on the surface. So that means that you cannot go to the atom. Okay, let me first of all put these atoms at the place where we were having it. Okay, so let's look upon question again. It says that the shortest distance on the surface between the two opposite corners. So the distance, when you are calculating the distance, you cannot calculate the distance through this. This is not the right way. Okay, this is not the right way. Why? Because you are going inside the cube. You cannot calculate the distance inside the cube. They have asked you to calculate the shortest distance on the surface. Okay, so you have to calculate it through the surface. Okay, this is the key of this question, or this is the point of the question which is going to be, which we are going to discuss. So on the surface, how you can reach out to this particular thing. Okay, so to reach from the surface, you have to go somewhere, like this is how you can go. Okay, you have to go in the backward direction, and then you can go like this, and then you can go like this. But is this the shortest path? Like, you are going along the surface. So if let's say, if I take a cube, okay, let me take a cube for you guys and then explain, because then it will become much easy to understand. All right, so I have just bought this cube just to explain you this particular part. Okay, because I just got this, and this is not perfect cube, but let me explain you. So these are the two opposite corners, okay, the one which I am touching with my fingers. These are two opposite corners, but you can reach to this, like you can reach from here, like the one which is here on this hand till here through the surface. Okay, so how you are going to go? You are going to go like this, okay, on the surface itself. You cannot reach to this place to inside by going inside the cube. You have to go through the surface. I hope you understood what I am trying to say. Okay, so for this, to solve this question, you have to unfold this cube. Okay, you have to open this cube, and then you can do this. Let me show you how you are going to do. Let us go back to pen and paper to see how you are going to go. But I think you got the point, right? These are the two opposite corners of the cube, but you cannot go from inside, and that's why root 3 is not the correct answer. Okay, so now let's look upon how and what is the correct answer for this. Getting back to solve this question again, so let me remove this red line, because this is certainly not the shortest path. This is the longer path. You go like this, go like this, go like this, so that's not the shortest path. So I'm just removing this. Okay, now you have to imagine that this is one of the face, right, the top face, and this is another face which is on the back side, right? So your atoms are only on these two faces, on the top face over here, and on the top face over here, and on the back face. You just need top face and the back face. These two things you need. Okay, rest of the cube you don't need. So let me just redraw this, and let me just open this cube. Okay, and we just need these two boxes, like these two faces on which we have our atoms. Let me draw. So I am going to draw the top face. Okay, and just to make sure that you can see everything, let me number it up. So I have 1 2 3 4. Okay, just to make sure that you understand. And in front of 3, or which with connecting to 3, I have 5, then 6. Okay, so it's like that. So let me draw this. So this is, let's say, top face. I am shading it with this cyan color or blue color, just to make sure that you understand that which face I'm talking about. Okay, and if I number it, let's say 1 2 3 and 4. Okay, so I have atom at position 1, so I'm keeping atom at position 1. Okay, and then I have the other face 5 and 6 is joining 2 and 3. So 2 and 3 are joined with 5 and 6. Okay, something like this. And with 3 you have connected with 5, and then you have 6, and I'm going to shade this green. So we are talking about these two faces here. Okay, the top face and the back face. Got it? And you have another atom at position 5. So let me place this atom at position 5. So I hope you understood how I have opened the cube. There are other faces also, but we don't need those faces. That's why I'm not showing that up, because that will that is going to confuse you more. So just two faces are needed. I have just opened these two faces. Okay, so let me draw it again over here for you. So if I just write down the units of all these faces, so how much it is. Okay, so you know, from here to here, all these cube is going to have all the sides same. So this is 1 unit, like this distance is 1 unit, and this distance will be 1 plus 1, right? Because two cubes or two squares are there. So this is like 2 units, right? This length. Understood? When you are going to open. So now you have made a rectangle actually. So you have now a rectangle of length 1 by 2. Okay. Now I'm not going to make two boxes. I'm just going to make the overall figure. And you have a here and here. And now the shortest distance between these two is actually this. This is your shortest distance on surface. Got it? And this is 1 unit and this is 2 unit. So you know this is a triangle, and if I make it, let's say if I call it triangle A, B and C, So I know that AC square is equals to AB square plus BC square. AC square is what I need to find out. That's my shortest distance which is asked in the question. And AB is 1 square plus BC is 2 square, right? 2 square. So AC square will be 1 plus 4, or AC square is going to be 5. AC will be under root 5. And under root 5 is 2.24. Okay, that's the right answer. Okay, this question is not challengeable and the answer given is right. Under root 5 is the right answer. Now you will ask that how you will find out the shortest distance in this. You have opened and now you are doing all these things. Like, why to open this? Because you have to go through the surface to reach out. If you will just ask me to draw the shortest path on a cube, like if you want me to draw a shortest path on the cube, how I'm supposed to do. So basically I will go something like this. I'll go along the surface here and then over here. So although it looks like bent, but when you open this cube, this line is straight, which is going to be something like this. So you have to go through the surface through the shortest path. I hope this makes sense. Because it's a 3D related question and a lot of imagination is needed, I tried to explain from the best what I could. Okay, I hope you got the understanding of this question. Do let me know if you guys have any questions related to it. If you guys have any other arguments, we have, like, the comment section is open for discussion. So yeah, among these two, I believe that this question is challengeable. 701158 definitely challengeable, but 701107 is not challengeable. The answer key is right. All right, do let me know what other questions you guys want me to solve. I'll try to do them very quickly. So yeah, take care. Bye bye. See you in the next video. Also, one more important thing which I wanted to mention before ending this video, that we have launched our new batch for the next CSIR next net exam, which is supposedly we are expecting it in June, but like, of course, it will be either in July or August. So the next CSIR net exam will be 2025 June 2025 exam. Delta batch for physical chemistry has been launched. All these classes are in detail over there. All the physical chemistry related lectures are there. Along with detailed lectures, you also get mock tests over there. There are 3 types of mock tests in the course. One is your topic wise mock test. So after completion of every topic, you have a mock test. Then you have mixed mock test, where minimum 3 topics are mixed together. The questions from 3 topics are mixed together. And then you also have a full length mock test of physical chemistry. So all the questions of physical chemistry are merged, or they are mixed together in that particular mock test. So this course is going to give you a good and idea how to solve questions and how to prepare for CSIR net exam. If you are having trouble, especially with physical chemistry, this course can help you a lot. I have been teaching on this particular course since this is the 4th batch now, and we have got some very good response in the past. So I believe this is going to definitely help you. If you are willing to join this particular batch, the link is there in the description of this video. The price for this batch for now is 2,500 rupees, and you will get all the batch till the exam is conducted. Okay, that's the duration, or that's the that's the tenure for which you are going to get access to this particular batch. So join now, and we can learn together for physical chemistry and for the next CSIR net exam if you are planning to give that. So that's it from my side for this particular video. I will see you guys in the next video. Take care. Bye bye.